Hi guys, Nexi here, back with another video, and this is FLSUN Super. And in this video, you will see why this 3D printer is now my favorite Delta style 3D printer. Stay tuned. Welcome back guys, and thanks for tuning in. This is FLSUN Super from a company named FLSUN. This Delta style 3D printer is capable of printing models more than twice as fast than a normal Cartesian 3D printer, and still maintain high print quality. For example, this is a 3D Benji and boost of Deadpool printed at 150 mm per second. A very impressive high-speed prints. Now let's dive deeper into this review, starting first with the specs and features. This Delta style 3D printer has a print volume of 260 mm in diameter by 330 mm on the Z-axis. It uses MKS 32-bit Robin Nano version 3 motherboard packed with a TMC 2209 silent stepper drivers that runs 48 mm large torque stepper motors. These stepper motors over the 10 mm wide rubber belts move the effector arms carriages that slides on a linear rails. The effector arms are made of super lightweight, strong carbon fiber, and they need no tools for assembly or disassembly. These arms are holding firm in a place with the springs, which is very good and smart solution. The print head have a clone volcano hot end with a silicon suck insulation, and there is a dual cooling fans on each side for filament cooling. Both cooling fans have a wide air nozzles which provide very effective cooling. Filament on this Delta are pushed through the Bowden tube by dual drive Bondtech clone extruder, which works very nice, and I had no problem with any kinds of filament, including the flexible ones that I tried. The machine used capacitive high-res touch LCD screen with a good brightness and nice contrast. The screen itself is detachable, and you can set your desirable screen place by moving this magnetic holder up or down, which is nice. The user interface is easy and simple to use, and there is 8 different languages to choose from. The screen have a quick and snappy touch response and a high print speed refresh rate, so that you can see your printing speed basically in real time. And I gotta mention the boot up animation, who looks really cool. Now the firmware that runs this machine are based on the open source Marlin 2.06. The printer have a good PID tuning, and it reaches and stabilizes the printing temperature very quickly. Also, this printer has a features like resume from power loss, filament runout sensor, and the auto leveling. In terms of safety, the printer have a thermal runaway protection enabled in a firmware both for hot end and for the heated bed, which is great to see. For auto bed leveling, the printer uses micro switch attachment that holds with a magnet on a print head during the auto level sequence. The auto leveling sequence takes a few minutes to finish, and since this print head never moves, you only need to do this procedure once. During my testing, I found that auto level works consistent and reliable, and still during this day, I did not need to repeat the process. The glass heated bed have a ceramic coating on the top, and it has a good adhesion. When it's hot, it holds the print strong in a place, and when it's cooled down, it pops up the print for the easy removal. I found that the filaments like PLA and PETG sticks very well to this surface. For ABS prints, the brim option is recommended, and for nylon prints, the brim option and some kind of glue stick is must to have for a successful print on the stock glass surface. Also, it's good to mention that heated bed have also thermal insulation underneath, which speeds up the heat up time and makes the heat bed more efficient. The printer has also a handy drawer compartment where you can place tools, accessories, and the spare parts. Now in terms of unboxing, the printer comes very well packed and secured with a lot of foam in a shipping box, so nothing was damaged. Once you open the package, the first thing that you will find is the instruction manual, which is nicely done and it's very easy to follow. There is also updated part of the manual which will tell you how to format microSD card to avoid any slowing down of the machine during the fast vase printing. And also, it will tell you how to flash the firmware if you want to switch the machine to do reading over the G-code over the USB port instead of the microSD card slot. One quick look at the towers, we can see the belt adjuster, linear rail, and the stepper motors also comes with some sort of sound installation damper, which is nice to see. The package itself, it contains of 2 layers. The first one contains the frame towers, effector arms, screws, spatula, cables, and tools, while the second layer contains the top and the bottom part of the frame, extruder assembly, printhead, accessories, and the remaining parts. Here, I took everything that was inside the box and I placed it on my desk. One quick look at the printhead, we can see that we have Volcano clone hot end with a silicon sack over the heat block. And there is a fan in the middle for the hot end cooling and 2 filament cooling fans on each side. Also, I need to comment on design and the look of the effector arms. They are very lightweight and they look nice and feels high quality. On each arm there is a lubrication grease, and I think that this design will be long lasting as long you keep them greasy. In the package there was also some white PLA filament, my guess around 200 grams, which is nice to see. And what I particularly like is how much of the spare parts you get in the box. You get a spare heat block with a heat break and a nozzle, spare block heater, temperature sensor, Bowden tube, and more, which is great. Beside manual in a paper form, there is a small and compact USB microSD card reader and no-name brand microSD card, which is placed right here in a very convenient place. On a microSD card you have a digital copy of the instructions, portable Cura 4.4, drivers, firmware, few test model prints and parts, and many links for instructions, videos, and troubleshooting, which is very nice. Now in terms of assembly, it was straightforward. The first step is to screw down 3 towers on the upper base frame. Every tower holds with the 4 M4 screws, which you need to screw down with the Allen key. Keep in mind that you should match the stepper motors with the cables that are marked with X, Y, and Z stickers. Next I place the frame base in a place and I screw down each tower with the same type of M4 longer screws. Then I install the holder for LCD, they just slide in these aluminum extrusions, and attach the LCD screen on the magnet. Now when LCD screen is secured, I rotate the printer nice and slow and I place it back on the desk. Now the printer is oriented like it should and the heatbed is in the bottom. Next I took the effector arms and I installed them on each carriage or slider and then on the printhead nice and slow. Since they don't need any tools, it was easy to install them. You simply stretch the arms and place them on the ball joint. Next step was connecting the printhead, so I free the cables from the upper side of the frame or upper piece and I plug each cable into the color matching plug. Then I took the extruder and installed it in the place and I screwed down 2 short M4 screws. Next I plug in the stepper motors and the filament sensor. Then I free the heatbed cable, I plug it into place and I hide the cable inside of the tower groove. Next I plug in the Bowden tube and I install the buckle which locks the tube connector. I tie the printhead cable and the Bowden tube with one cable zip tie and I install the filament spool holder with the 2 short M4 screws. The assembling at this point was complete and I would say that it took me less than half an hour to finish assembly with the supply tools. Now let's talk about the print quality. The print quality of this Delta in short is very impressive, especially at high speed. As you can see, I have printed quite a few test prints in a PLA, PETG, ABS, and TPU. So let's start first with a PLA and slicer software. In the Supply Cura 4.4 slicer, there is a preset printer configuration for Super Racer, and the 2 base print profiles, one called Fast, with a base speed at 150 mm per second and a 0.2 mm layer height, and one called Fine, set up at 80 mm per second with 0.15 mm layer height. My first test print was the test G-code that was on a SD card. And it looks to me that they are set to be printed in a fast mode. Printer took 38 minutes to finish, and the print quality was great. The models fit perfectly, and then I slice a 3D Benji in a fast mode and I start to print. Shoot it at 4K at 30 frames per second, my camera was struggling to capture the fast movements in the close-up of this printer, which was indeed racing over the print. The print speed on the screen was pretty much in a real time. And after 42 minutes, the printing of the fast 3D Benji, sliced with 150 mm per second, was complete. The results was very impressive. During my close-up look, I found some slightly ringing, but other than that, the print quality was great. And even the cooling fans was keeping with the print speed, which is nice. Next I print out the second Benji, this time in a fine print mode, at a base print speed at 80 mm per second and 0.15 mm layer height. That took 1 hour and 4 minutes, and the print quality was great as well. And here you can see both 3D Benjis, and I can barely see which one is which from the some distance. Only if you look close enough, you can see some trace of the ringing, and that gives away that this 3D Benji is printed at high speed mode, but other than that, they are both very similar, which is very impressive considering the high print speed, and I'm not even tied down the belts yet or did any kind of tuning. For those who are interested about the noise level, my dB meter shows around 35 dB on the standby and around 48 dB when it's printing, which is very good score for a 3D printer. Now to test out how good the auto leveling is and how good the first layer will be over the larger printing surface, I slice this model of Mandela and I scale it up to 200% scale. During the first layer, all the lines are printed nicely, and again I use the fast print mode to print this model. Printing took just over 3 hours to complete, and the results was great. I leave plate to cool down, and look how easy it was to remove this print. Nice. Here is a close-up look of the print, beautiful design model, and also print including the first layer. Next up, I slice and start to print FDM benchmark test, and for this print I use a normal speed at 50 mm per second, just like I use when I test out all other 3D printers in the past. During the printing everything was going well, and the retraction seems to be tuned very well by factory. In the end, this benchmark turned out almost perfect. The print surface was good, bridging, overhanging was good too. Only the print accuracy was just a tiny bit off, and I could not easily remove last 2 pins. So here I will just slightly lower the feed rate and tie down the belts just a tiny bit. That should do the job. Next I moved to PETG, and the first print was a model of the bolt and nut that I found on a Thingiverse. This print is a bit bigger than a model on the SD card, but I like how it's designed. Since PETG doesn't like to be printed too fast, I set the speed to the 70 mm per second, but both for inner and out walls, as well the infill, and the fan speed was set to 30%. The print turned out great, with all details, it's accurate, and the print and bolt are a perfect match. I also print one more pair, and I start to print 3D Benji with the same PETG. Temperature that I use was 235 on the hot end and 75 degrees on the heated bed. 3D Benji turned out perfect, and I'm very impressive how good the retraction was even with the PETG. There was no stringing, and the print quality was awesome. I also print out this carabiner with the same PETG, and they turn out great as well. With a 50% of infill, they are very strong. Nice. Next up was the ABS, so I print out the same models, 2 sets of the bolt and nut, 3D Benji and carabiner. Here I use the brin to make sure that print stays in place, since ABS loves to warp. I was able to print out these models without too much of the effort, and the print quality turned out to be very good with ABS, both on bolt and nut and the carabiner. Only the 3D Benji had some shrinkage layers here in this area, but that can be due to the cooling, as the cooling fans was set on 30% to start here to be able to print upper side of the 3D Benji nice and smooth. Some low speed cooling is necessary even for the ABS if you print some precise models at higher speed. Here is the example of printing of ABS with and without the cooling fan. It's a quite a difference. And now we are coming to the TPU or the flex filament. I print out the same set of nut and bolt as well the small vase. I kept the lower print speed and the print quality is really good. The bolts are nice and flexible, and the nut too. While the vase was a bit more tricky to print, so I set the cooling fan to the max to keep the thin walls of the vase as cool as possible. and I was able to print this vase only in one layer. One thing to keep in mind is that default feed speed for loading of the TPU is too fast, so manually loading is recommended. Now, since I print the vase in a TPU, I also printed the same vase in a PLA. But I think that these vases are too small, so I print one more vase, but this time scaled to 300mm. Thanks to the good part cooling fan, I was able to print this vase with 75mm per second and 0.2mm layer height in just over 2 hours. This vase came out beautifully and you cannot even see any layers. It really looks like it's a cast molded and not even 3D printed. Beautiful print. I love it. And the last print of this Delta Super Racer is the boost of the Deadpool printed at fast mode in 150mm per second. This print turned out awesome and I cannot believe how well it came out with this high print speed and without any supports. All details are printed very nice with barely visible ringing at some areas. The print surface is fantastic. Really impressive print. I love it. And the last test is the heatbed heat up time. This Delta Super Racer hit 50 degrees in 1 minute and 30 seconds, 70 degrees in 3 minutes, and the maximum 100 degrees was reached in just 6 minutes and 32 seconds, which is awesome result. Also, the thermal signature of the heated bed is nice and even. And now, the final words. Well guys, what can I say? I'm impressed. This Delta Super Racer, in my opinion, is awesome 3D printer for the price point. One of the best that I test out on many aspects. The print quality and the print speed are great, the build quality is good, auto level works perfect, it produces reliable and fast prints, and this machine is a great platform for the future upgrades and tuning. If we open the upper panel around the motherboard, we have plenty of space for Raspberry Pi and the Octoprint. The motherboard is MKS Robin Nano version 3.0, which supports many features, and it has many ports left for adding some new additional features, like a Wi-Fi for example, and with available firmware and the open source code, that will be not hard to do. The last thing to mention is the Super Racer owners Facebook group, in which you will find tons of useful info and plenty of help and ideas. Alright guys, I hope that you liked this video and found it useful. Link of this 3D printer and other useful links you will find in the video description. I wanna thank you for watching and I see you next time. Bye bye.